T-minus 30 seconds. T-minus 20.
Falcon 9's secured flight pressures.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the Falcon 9. Falcon 9 has cleared the towers. Team moved to section 10.59 to secure the pad.
Stage 1 propulsion is nominal.
Plus 1 minute into flight. Falcon 9 is heading downrange after lifting off from Space Launch Complex 40 at Cape Canaveral. Currently, the Merlin 1B engines are operating at full power. We're watching the launch from the SpaceX cameras on the ground at Cape Canaveral. Right now, this Falcon 9 is heading through the supersonic phase. It's a little hazy to see on the webcast as we head out into space. We've gone supersonic. You've also heard the call out, MVAC chill has begun. Just like we do with the first stage engines, we are now chilling in the turbo pump on the upper stage engine to get it ready for ignition. Coming up just before T plus 3 minutes. Currently the team is reporting Falcon 9 is operating nominally. Major event coming up in about 30 seconds is shutdown of the 9 Merlin engines. Let's listen in for the call out of main engine cutoff. Shutdown, successful stage separation, and the view from the first stage looking at the second stage. The upper stage engine has ignited. We're on our way into the parking orbit. Let's go down to the floor and talk with the team.
With successful separation of the first and second stage, we now continue on as the two separate stages perform their separate responsibilities. You were just looking at a view of first stage pointed back down towards the Earth. Second stage is continuing on, and we've just had confirmation that the fairings, the encapsulation at the tip of second stage, which holds the satellites, has successfully separated, an important milestone.
Yeah. Breaking the fairing away like that allows the MVAC second stage engine to perform a little more I guess robustly. It's efficiently, right? It's putting more of that force into accelerating the satellite. The fairing is essentially dead weight once it gets out of the atmosphere. It's very important before that point.
Exactly. So the less weight we can have around the payload and on the second stage, the more efficient the vehicle itself will be, and allowing us to use less fuel in order to get it out to the specific place that we're trying to drive these two satellites to.
Right. A lot of people don't realize we don't need the fairing anymore. Once we're out in space, the fairing is there to design both protection and aerodynamics of the satellite. When we're going through the atmosphere, that needs to be able to push through air very, very cleanly. Without any air anymore, when we're out in space, we don't need that fairing, and so we let go of it.
And while the second stage is continuing to speed up to get into low Earth orbit as the beginning of that geostationary transfer orbit, the first stage is headed back towards the drone ship in the Atlantic Ocean. And you saw a cool shot of the grid fins popped out there. And the grid fins are what's controlling it back through the atmosphere in order to get it to approach the drone ship successfully. There we go, you can see them right there.
And those conjoined triangles of success that you see inside of the grid fins are actually just like small airplane wings. They're used to fly the first stage back to the destination of the drone ship that it wants to reach.
Yeah, so the grid fins are actually one of the mechanisms that I support in my day job on the manufacturing of those. And the reason why we can't really show them to you in person is because they're really big, right? They're made out of aluminum. And we use about, well, let's see, I'll step in front. So they're about this wide and they're about that long. So they're pretty heavy, they're pretty strong, and they're a lot bigger than what you might anticipate just based on the views that you get from the side of the rocket.
Interestingly, they're most useful at hypersonic and at lower velocity speeds. The shape of that sort of crosshatch pattern is such that the shocks that develop from just airflow mean that most of the air around the speed of sound at those sorts of speeds flows around the grid fin, so you actually aren't as efficient in steering the vehicle around the speed of sound. But very high above the speed of sound, you're getting good control, and close to sort of lower in the atmosphere when you're moving slowly, you also have that good control again.
And so we're going to transition into the phase where we do the re-entry burn. You'll see these grid fins deploy like little T-Rex arms in a few seconds after the re-entry burn once we're within the atmosphere.
Plus 6 minutes and 31 seconds. Everything's looking good as Falcon 9 heads to space. Currently on the trajectory plot, we're headed, as usual, right down the middle of the road between the predicted upper and lower limits projected on the map. We're listening. We've just heard the call out for entry burn startup. This is a 3-burn maneuver that brings the first stage, slows it down to get it ready to come back through the atmosphere. Now, previous flights, we've done a boost back burn. If we were coming back to the Cape, we don't do a boost back burn in this case. We're doing the entry burn. We're waiting to hear the shutdown. And we've got the shutdown. And we'll then listen and wait for the first stage to come back. Meanwhile, the second stage continues to perform nominally as we head into orbit. You can see the glow of the nozzle on the MVAC-D engine. That's our niobium alloy nozzle. That red glow that you see right there on the close-up camera, that indicates temperatures are nominal, a word we like to use here at SpaceX. So at T plus 7 minutes and 42 seconds, everything is go.
Okay, so like John I said, the first stage and the inner stage are coming back down. We're waiting for the re-entry burn to begin any moment now. This is the burn that slows the vehicle down enough so that it doesn't burn up upon re-entry, because given that this is a GTO mission, like we've said before, this is a rocket that's coming back in really hot and really fast.
Yeah, most mission profiles, we typically have 3 burns. It's boost back, then re-entry, then the landing burn. This one, we don't have a huge lofty perspective. We're going much more flat, so it's just re-entry and landing. We're coming into the landing burn now, and you should be able to see it on your screen.
If footage cuts out, we find that the drone ship shakes a lot with that final few seconds as the force from the engines comes down. The landing burn has begun.
You can see the drone ship shaking.
Looks like our feed may have froze a little bit. Again, intense vibrations from the drone ship due to the rocket landing.
Smoke.
Smoke clearing.
Smoke.
I see a vehicle.
I see somewhat of a rocket. Move, smoke.
Fingers crossed.
We don't know.
You're seeing what we're seeing right now.
See.
We should be able to have some conclusive evidence in a second once we reestablish video.
You can hear as the footage is coming in and out how everyone's excited.
We're unsure of the status of the landing.
So we'll provide updates when we know if that first stage landed or not. Once the smoke clears and we have confirmation, we'll be able to say yes, it successfully landed, or no, we simply got more experimental data. So we'll return with that in a moment, but now focus back on the primary mission, which is second stage in orbit.
So the animation that you were just seeing on your screen is a good orbit, we're hearing, is what that animation is showing. You can see where the second stage is in relation to the Earth and how it's continuing. You're hearing the crowd react to that jumping footage of the first stage on the drone ship.
We don't know yet, just like you guys don't either. But again, the focus is the second stage, and it continues on in low Earth orbit to take us to that geostationary transfer.